Yeah, let's start. Am I audible to everyone?
Yes.
Yeah, yeah.
Yeah.
Yes.
So first half an hour or 45 minutes, we'll be talking about logistic regression. Then if you have any doubt on the previous part or simple linear or multiple linear regression, we'll do the division part. Okay. So what do you mean by logistic regression? Means what is the difference between uh, linear regression and logistic regression? Can anyone tell me? There is a confusion, right? When to use multiple linear or simple linear regression or multiple linear regression or logistic regression. Don't you get confused in this particular technique? When to use what? I'm audible to everyone, right? You can,
Yes, yes, you are audible.
yeah. So
One is
what
the
is your,
linear regression, and it is
Yeah.
logistic is non-linear regression. Yes.
sorry, can you repeat?
Logistic is for non-linear variables, I guess. And the
Yeah,
part
that is correct. But what do you mean by linear and non-linear? If you have some data set, how by looking the data set, how do you understand that what technique you will be using? Linear regression or logistic regression? That is quite difficult, right? Theoretically, you are correct.
No,
Logistic means
dependent variables are when discrete in nature, we will use logistic.
uh, yeah, correct. So logistic regression is that when dependent variable are categorical in nature. Okay, you might have heard this term. There is one type which is called binary logistic regression. That is the popular kind of logistic regression we are using. So in binary logistic regression means the dependent variable that will obviously be in categorical in nature and that will have two possible outcomes. So if I say gender, gender, there will be only two possible outcomes, right? Forget about this new tradition. That is a third gender also. But if we talk about only male and female, so there will be only two categories. Okay. Suppose I'm asking you whether you're gonna attend my today's session or not. So what will be the answer? Answer will be either yes or no. There should not be any other answer, right? The
Yes.
answer will be either yes or no. Someone is asking you that whether you gonna attend today's BA session or not. So there will not be any third type of answer. Okay, so this kind of things we can apply for logistic binary logistic regression. A dependent variable is having only two categories. Okay, got it. So in linear regression, the dependent variable will be continuous in nature, but in logistic regression, the dependent variable will be categorical in nature. So I hope you all know what is the difference between categorical and continuous. Continuous means age, weight. These variables are the example of continuous types. Okay, and categorical means either there will be two categories or three categories or four categories. Depends on the nature of the data set. Okay. So this you might have heard this term, machine learning. I hope. So machine learning, there are mainly three types: supervised, unsupervised, and reinforcement learning. So in supervised learning, there are two types: regression and classification. So classification technique. So logistic regression used for classification. Logistic regression is a classification method. So we do classify those things. Okay. We have some data sets. As per those data sets, we do classify those. Suppose I have collected a data from you that whether you want to attend my today's session or not. Okay, got it. So there will be if I classify those, someone will say yes and someone will say no. So I can classify those into two categories. Okay, so logistic regression helps in categorizing the entire data set. Got it? Any doubt till now, anyone? So there will be some input data. Obviously, that depends on, suppose if you are busy, after being busy also, you're gonna attend my today's session or not. So X1 will be that you are free or you are busy kind of thing. X2 is that how much you are interested, suppose. How much you are interested. X3 is that you really require this help or not. Something this kind of variables. And there is a hidden layer. This in this hidden layer, the data will be analyzed, and after that we'll classify those data, whether you want to attend or whether you wanna uh, you don't want to attend today's session. Okay. Example is clear, or do you want any other example?
Another
Example is
example.
clear. Yeah, I'll come to that. Example part, I'll come to that. Okay, so I've already told uh, logistic regression. It is in statistics, logistic regression or logit regression or logit model. Those all are similar. It's a regression model where dependent variable is categorical in nature. Okay. So logistic regression measures the relationship between the categorical dependent variable and one or more independent variable by estimating the probabilities using a logistic function. So there is a particular function, logistic function is there to analyze those uh, categorical variable in nature. Okay. So which is cumulative logistic distribution. The distribution is known as cumulative logistic distribution. Okay. The example, this example you can relate uh, the spam of email, whether this email is spam or not. How do you find that? I mean, how the your Gmail automatically analyze those data, right? Whether to send this mail into your inbox or whether to send it to your spam box, right? Kishore, you are asking that, asking for example, right?
Yes, yes.
Yeah. So how do this Gmail actually does this analysis? Whether to send this particular mail into your primary email box or inbox or it send it to spam box. So this totally depends on the machine learning technique what they have implemented in that particular software. Okay. So this is kind of categorical in nature, na? Email is spam or email is not spam. So for the analyzing this kind of data, we'll be using logistic regression, right?
Okay.
Can you please
Okay.
explain the cumulative logistic distribution?
I'll come to that. The functions or formulas we'll see. It's
Okay.
just the theory part, definition. Yeah. So in linear regression, you find that the curve looks like a straight line, right? In linear regression, the curve will obviously be in straight line.
Yeah.
Okay.
Yes.
But in logistic regression, the curve will similar to look like a S-shaped curve. So this is called actually the typical statistical term. This is known as sigmoid curve. What I said, it is sigmoid, SIGMOID, sigmoid curve. Okay. So in linear regression, as it is a continuous type data, so there might be a chance that uh, this limits you can find this limit is 0 to 1, right? In logistic regression, the limit is in between 0 to 1, but in linear regression, this limit can be exceeded. But in logistic regression, the limit should be either 0 or 1. Okay. Are you getting it? Logistic
Yes.
regression. Yeah. My dependent variable will be either 0 or 1, means either yes or no. Got it.
Yes. Got it.
So I want to give one example or I want to ask you something. Okay. My question is that I'm showing you one apple and I'm asking you what is the color of that apple? What will be your answer? What you have read in your nursery school level. Apple is red in color, right?
Yes.
Red
Yes.
and green.
Forget about the green one. What
Yeah, it's
what you
red.
have read in your, yeah, what you have read in your nursery standard. Apple is red in color. So can you tell me how much red it is? It depends, right? Every time, is the color uniform to each and every apple? The red
No.
color,
No.
is that uniform to each
No.
and every apple? Don't write in the chat box. I can't see.
No, no, no. It's
Yeah.
not.
So if I ask you, apple is, suppose my statement is apple is red in color. So you have to say either yes or no. So how do you fix that particular standard of redness of apple? Are you getting my point?
Yeah, by taking some percentage.
What percentage?
Like full red is equals to 100 and nothing like some whiteness is equals to 0. So between that we can rate it.
Yeah, but my statement is apple is red. Apple color is red. Whatever I'm showing you the apple, I'm showing you an apple and I'm saying that apple color is red. So you have to say whether yes or no. So how do you fix that? I hope you all getting my question.
When it's not red or it's red.
It will obviously be red, right? Forget about the green one, green apple right now. The apple will always be in red in color, whatever the color brightness fluctuates. It will obviously be red. So this point 5 is the threshold limit, the threshold value you can say. So what Kishore was saying, he was quite like nearer to the answer. So whatever I'll fix my threshold limit in a certain point. Generally, we do fix the threshold limit in point 0.5. Okay, so 100% or probability 1 means the apple is fully red. Okay, and 0 means apple is not red, or opposite. What is the opposite color of red is suppose white. Okay, apple is white in color. So in between point 0.5 to 1, if the color range is in between point 0.5 to 1, so I'll say apple is red. Okay, my answer will be a particular answer. Apple will be red in color. If my if the apple color is in between point 0.5 to 0, in this particular range, I will say my apple color is white in color. Are you getting my point?
Yeah, getting it.
Yes. But how will I fix that threshold value? How will we get to know that this is a threshold value?
You have to fix that in a particular limit. Suppose we are fixing the color range, right? 0 to 1 or 0% to 100%. So this color range, you can do that in using different kind of softwares. You can fix that color. If you are matching your apple color into that particular color scale. Yeah, let me give you an example. Have you heard about heat map? Heat map, have you heard about? I hope everyone heard about heat map during this COVID-19 scenario.
Yeah.
Deepak, you know or not
Yes, yes.
heat map?
Yes, yes.
The COVID statistics actually shown using that heat map statistics in Indian map, right? So the color range is fixed, right? Some suppose 10,000 cases means red in color and 0 cases mean purely green in color. Okay, so this color range will vary.
Yes, yes,
Got it?
got it, got it.
Yeah. So depending on the color scale, and you can compare with your apple color, and now you can rate. If the apple color and your color scale range is lying in between, apple color is lying in 0.5 to 1 scale, I'll say apple is red in color. But in between 0.05, 0.5 to 0, I'll say apple is white in color, because my answer should be either of two categories to run the logistic regression. Okay, either 1 or 0, yes or no, right? So while talking about this, there is another term which is known as fuzzy logic. So fuzzy logic means there should not be any proper answer in this particular scale, 0 to 1 scale. There should not be proper answer. Means you can't say apple is red in color, you can't say apple is white in color. So this is how we are dividing it by keeping a threshold limit. This apple color comes in example, apple color comes under the logic which is known as fuzzy logic. Okay, if you are interested, you can Google this term, what is fuzzy logic, and you can check that. I hope basics of fuzzy logic is clear. Fuzzy logic is when you can't say some answer in a proper way. Example is similar to that apple example. Okay, clear everyone?
Yeah, got it.
So when apple color is scaling and the scale matching with apple color is 0.8, so what will be your answer? Yes, apple is red in color, right?
Red.
Yeah. And 0.03, apple is not red. So yes or no?
Excuse me, Bhaiya.
Yeah,
I have a doubt. Like, if point is coming directly on the directly on the threshold limit that is on 0.5. So, in which category we will be considering it?
I was expecting this question. So that depends on the researcher whether you want to take it or not.
Okay, okay, Bhaiya.
This is kind
Thank
of
you.
research problem, right? So you want to take it or not? You can reject it. Like if your aim is that you want to take, suppose there are some apples in a basket and you want to take only the red apples. Okay. So in that particular scale, so one apple is coming the scale in this particular scale, one apple is coming in 0.05. So that totally depends on you whether you want to take it or you want to reject that. Depends on the researcher. Okay.
Okay, I got it. Thank you, Bhaiya.
Yeah. So this sigmoid curve, this sigmoid function, how does it actually working? The logistic function is also known as sigmoid function because this curve is a logistic curve, and this curve is known as sigmoid curve. Okay, so it's an S-shaped curve that can take any real value number map in between 0 and 1, or you can say 0% to 100%, but never exactly at those limits. That is why we're talking about threshold limit. The example, I guess the apple example is very much relevant, and you can easily understand and you can easily remember that. So this is how we represent the sigmoid function. You can remember this formula. If, uh, if it's, I don't know whether it's there in your syllabus or not. You can remember this formula. Okay.
Hello.
Yeah.
Both are same. Sigma function and logistic regression. Both are same.
Yes. Logistic function
Okay.
and the sigmoid function both are same. You can see that
Okay.
this is the sigmoid function, right? 1 by 1 plus e power minus x. We can compare that.
Yes.
Wait for some time.
Okay.
Yeah.
Mhm.
So there are several types of logistic regression. One is binary logistic regression, what I was talking about. So independent variable, there will be only two categories. My email is spam or not. Okay. Next is multinomial logistic regression, means there will be more than two categories in the dependent variable. Okay. So this example, you are vegetarian or non-vegetarian or a vegan. Okay. Next is ordinal logistic regression. So ordinal logistic regression means you are ranking something on a rating scale. You are ordering. Suppose a particular movie you are ranking on a scale of 1 to 10 or 1 to 5. So this kind of uh, This kind of data will be and comes under ordinal logistic regression. Okay. Next is decision boundary. We have already talked about it. So the threshold limit, whatever you want to fix. If you are suppose I'll come to an example actually. The bank example, the credit card part. Credit card, whether you want to issue a credit card to a particular customer in a bank or not. Okay, so credit card, if you want to issue someone a credit card, so their credit score, you want to check their credit score, right? There's several aspects. One is the credit score, the best independent variable you can say. So dependent variable will be you want to issue the credit card or not to someone. And your independent variable, I want to take one independent variable right now. So my independent variable will be the credit score of that particular customer. Okay. So you being a manager, you can fix that threshold limit. So my threshold limit right now I'm fixing at 0.5. If the customer's credit score is more than 0.5, then I'll be issuing the credit card to him. If the credit score is less than 0.5, I'll not be issuing the what to say the credit card. Got it, everyone? The example. So threshold limit is depending on the researcher or the uh, person who is actually involving to take decisions. Okay, I can fix it to 0.4 also. If I'm a what to say strict manager, I can fix it to 0.4 also. So if I fix it to 0.4, that will be like I'm a strict manager or I'm a lenient manager. What is your call?
Strict.
Strict or lenient? Think about it. What it is.
0.4, it will be lenient.
Yeah.
Because less than 0.5, no, that's why it's
Yes.
Yes. My aim here is I have fixed it to 0.4. So less than 0.4 means I'll not be giving. So previously during when my threshold limit was 0.5, so 0.45. Suppose someone's code is 0.45, he was rejected, right? Right now he is accepted. So I'm a lenient manager now.
Yes.
Yeah. So what is this? This function, what it is known? This is the probability, right? Probability of the logistic regression equation, right?
Yes.
Yes. So you have to remember this. Yeah. So to remember this equation, they'll give you all those things like beta naught, beta 1, and they might ask you to calculate the probability. Okay. Logistic regression, you can expect easy question, all based on the calculations. One another term is that odds ratio. So how do you find odds ratio?
Can you show that equation once again?
Yeah. It's there in the book, I guess. This is written as E of y equal to P of y slash x equal to e power beta naught plus beta 1 x divided by 1 plus beta naught 1 plus e power beta naught plus beta 1 x.
Thank you, thank you. You can switch the slide.
Yeah. So another vital term is the odds ratio. So odds ratio, how do we find that? There is a long formula, right? Do you remember that formula? If you don't remember the formula, then another short formula is there, e power beta, right?
Yes, e to the power beta.
Yeah. So e power beta will give you the odds ratio for all those particular dependent or independent variable what you have taken, the intercept part and then sorry only the independent variable, not dependent. you can calculate easily. You will be knowing the beta value, right, for the intercept and then all the independent for all the independent variables. So if you know the beta value for all the independent variables, you can easily calculate the odds ratio from there, e power beta. It's actually e power beta I. So for intercept, it will be beta naught. Then for the first independent variable, it will be e power beta 1, then beta 2, like that. So the odds ratio has a range of 0 to infinity. E power something, it will not be in negative, right? If you think about mathematical logic. Are you getting it? You can reply. Are
No,
you
please
getting it?
repeat.
So e power beta. So this e power beta term or the odds ratio, this range will lies between 0 to infinity. Okay.
Okay.
So this one, like you have to calculate. You have to know the formula and you have to calculate. There will be some missing values. I'll run the logistic regression using SPSS, so I'll show that time. Okay. Just know the theory part right now. Yeah, this is the last slide I had. Yes. Next is I guess I don't need to say about the equation, logistic regression equation. You all know the logistic regression equation?
No, no.
Okay, then wait, I'll present my screen. 1 second. One second. Yes. So how do you write that? You all know the equation for multiple and multiple linear regression or the simple linear regression, right? Y cap is equal to beta naught plus beta 1 x1, like that you have to write. Am I correct?
Yeah.
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 So
Yes.
your logistic regression equation we do write as E of y. Am I correct? You want to check? You all know, I guess. Then e power all those particular terms, beta naught plus beta 1 x1, and it will keep on continue till beta in xn, right? Then in the denominator part it will be 1 plus the same thing, e power beta naught plus beta 1 x1, like that it will keep on continue till beta in xn. This is the logistic uh, regression equation. Okay, so if you know all those particular values, you can easily predict the ey or the y cap value. Got it? Got it?
Yeah, got it.
Yes. So this is
Hello.
one term. Yeah.
What is that ending part? Beta naught plus beta one x1 plus daughter like
Yeah, but plus dot dot dot, it will till keep on continue till beta and xn. How many variables, how many different variables you are taking?
okay, according to variable changes, right?
Yeah, yeah. Beta 1 x1 plus
Okay.
beta 2 x2 plus beta 3 x3, like that it will continue. Na?
Okay, getting. Okay.
Yeah. Next is, so how do we write the hypothesis for logistic regression? How do you write hypothesis?
Check. Fit or not fit.
Fit or not fit? Means the model is fit or not fit. That is the Hosmer-Lamso test, not the logistic regression. Good. The Hosmer-Lamso you might have heard about, right?
Yes. Sorry.
So Hosmer-Lamso is the test for goodness of fit. I'm talking about the logistic regression hypothesis. How do you write it? Logistic regression hypothesis. So H naught will be beta.
Beta 1 equal to beta
Beta 1
2 is
equal
equal to
to
0.
beta
Beta
2.
2 is equal
Like
to
that
0.
it will go. Yeah, right. We'll keep on continue till how many beta, how many independent variable you are having. Then what will be H alternative? H alternative will be, you can't write, right? Beta not, sorry, beta 1 not equal to beta
Not
2
equal.
not equal to 0. Can you write that?
No.
I am talking about, can you write this? Beta not equal to beta 1 not equal to beta 2 not equal to 0. Can you write this?
No, not easy.
This is totally wrong. You have to write it in a statement form. So the statement will be one or both the parameters is not equal to 0, or one or both the beta are not equal to 0. This is
Can we write?
also one.
Hello?
Yeah, go ahead.
Can we write like this? Like all independent variables are not equal to 0. Mm.
Not independent variables, this is beta term. You have to write in the form of beta, the parameters I'm talking about. Beta is a parameter, right? We are representing the hypothesis in the form of like using the parameters. So this is one condition. All the, when I'm talking about, when all the betas are not equal to 0. So there might be another condition, right? When beta 1 is not equal to 0 but beta 2 is equal to 0. This can be one condition also. So it's better you write in the form of statement. So if you want to write it, you can write H alternate will be one or both the parameters is not equal to 0. Done. Odds ratio I've already talked about. Next is the logit. What do you mean by logit? You all know what is logit?
Logistic, no?
Logistic is different. The logit model is different. Logistic is that particular equation previously I had written that. That is a logistic equation. The logit equation is, what is the logit equation?
Hello.
Can
Hello.
anyone tell me? Yeah.
Can you say like what we need to write on HA alternative hypothesis? Like that statement I'm asking.
Alternate is one or both of the parameters or both of the beta, you can write. One or both of the parameters is not equal to 0.
Okay. Okay.
Yes. So logit we do represent, sorry. Logit we do represent, what happened? क्या हो गया?
We don't know, I think.
ये लिख
We
क्यों नहीं
have
रहा?
no logic.
Yes. So logit we do represent as g of x. Okay. Logistic regression, how do I was representing e of y, right?
Yes.
So g of x is equal to, if you remember that logistic regression equation, it was e power beta naught plus beta 1 x1 plus beta 2 x2, like that I had written. Okay. So logit is that g of x is equal to only that power term what is there in the e power format. So beta naught plus beta 1 x1 plus beta 2 x2, and it will keep on continue till plus beta n xn. Got it? This term you have to write in the form of how many x you have. So g of x1 comma x2. So I have taken till xn, right? So I have to write in the like this only, not g of x. It's better you write g of x1 comma x2 dot dot till xn, as I have taken here till beta n xn. Got it? So if they ask you to find or find the logit of this particular logit model, or the derive the logit function of this particular logistic regression equation, so you all know the beta values. You can get it from your output. Okay, so if you all know the beta values, you can directly write the logit model, right? Clear, everyone?
What does it mean? Means what does logic mean? I didn't get it. Formula I got it, like that we have to calculate. But what is logic? I didn't.
The power form is actually known as logit, the e power form. Whatever you have written in the power format, na, this is known as logit. There's a particular term. This is known as logit.
Okay, then e function of y equals to e to the power g function of x by 1 plus e to the power g function of x, like that.
Yeah, you can write also this one. Yes. Whatever you have written in the power e power format, that is known as logit. Yeah, everything.
And any significance of that term? Like
No,
what does
just
it signify?
no, just for like
Okay.
they have named it as per the model or logistic regression equation. They have named it as logit function. Okay. Next is another two term is there, wall test and Hosmer-Lamb-Show. Wall test, you all know what is wall test. Do you all know wall test?
No, I don't.
No, it's not even in the book.
It's there in your syllabus or not? Can anyone confirm if it's done in your class or not, so that I can proceed, or else we can leave that? Because logistic regression, there is a very small part in BA2. Only direct question will come. Like they'll give you like all those values, and you have to find like using the equation, you have to find the values.
Walt's chi-square is written.
Yeah, wall
Chi
chi-square.
square.
Yeah, wall chi-square, and another one is Hosmer-Lamb.
Hosmer-Lamb-Show test.
Yeah.
Yeah.
So it's there in your syllabus.
Yes.
Yeah. So wall test is that the null hypothesis of the wall test is the parameters is equal to some particular value. Okay. So you all remember how do we find t statistics in simple and multiple linear regression? If we know the beta value and the standard error, how do we calculate the t value?
That SB upon SB1, I guess, mostly like that.
It was b by sb. So the beta value divided by the standard error.
And
So wild test is also same. So wild means in place of t you can write wild. Okay. So your wild test value will be the I'll show you better I'll show you the output. Okay. So you can write they might ask to write what is the null hypothesis for wild test. Okay. One more question. Do you want to write it? The null hypothesis of wall test.
Yes.
So null hypothesis of wall test is that h naught equal to set of parameters are equal to some value. There should be some value, means there's the parameters should not be equal to 0. Are you getting it? In the logistic regression equation, what was the null hypothesis? Beta no, beta 1 plus beta 1 equal to beta not beta 1 equal to beta 2 equal to 0, right? But here the null
Yes.
hypothesis, the set of parameters equal to some value. Okay. So let me show you one another one theory part. Let's complete the Hosmer-Lamso here theory part. So how do you calculate the wall test this wall test value? That might come like wall chi-square value. How do you calculate? That might come in your exam. So I will show you in the output while I will be talking about the output. Next is Hosmer-Lamso. So Hosmer-Lamso is used for to check the goodness of fit. Okay, the model is good or not. So null hypothesis of Hosmer-Lamso is fit is good, and the alternate hypothesis fit is not good. Okay, based on the chi-square value, we will calculate, and the chi-square value will compare with the p-value. Then we'll say whether we have to reject null hypothesis or not.
Can you repeat this statement which you said now?
Yeah,
Just
null hypothesis is fit is good, and alternate hypothesis fit is not good. These two they asked in
What was the alternative hypothesis for wall test?
the reverse, obviously. Null hypothesis was the set of parameters are equal to some value. Set of parameters will not equal to be some value. Okay.
Okay.
If you know the null hypothesis, you can easily write alternate. That will be the reverse of the null hypothesis. No?
What is the another test? Wall test and the second one?
Hosmer-Lamso. You want to know the spelling?
Without, yes.
Hosmer Lemshow. Yeah. Yeah.
And the
Now
first,
see the output. Sorry.
and the first one as well.
First one was WALD. WALD. WALD test actually, but statistics we actually know as WALD chi-square statistics. Yeah. Can you proceed to this output part?
Yes.
Yeah. So I have this data set actually. There are almost 23 independent variables and one dependent variable. So this data set, if you can see this bar, the data set is default of credit card client. So whether this client gonna default uh, credit card or not. Okay, means the manager want to know whether they have whether he can issue a credit card to the particular client or not. Okay, so there are several dependent variables like limit balance, how much balance this particular customer is having in his account, his education, his gender, whether his marital status, his age, pay 0, pay 2. This is the different variables. So if you want to know in detail, pay 0 means history of past payment, the payment status in September. This data is of 2005 data, 2004-5 data. So history of past payment. This payment status is in September. So September 2005 till that day the history of payment. Next pay 2 is the payment history status in August 2005. So there are several variables. Okay. So let's not get into all those things. So what I'll do, I'll take 2 or 3 variables from here. The bill amount 1, 2, something is there. So what is bill amount 1, 2? Bill amount 1 means amount to bill statement till September, in September 2005. In that particular month of September, uh, bill amount to is amount of bill statement in August 2005. So to check several things now, then only we will issue the credit card. Or if you can replace this credit card with loan, we do while giving approving the loan to a particular client or the customer, we do check several things, right? How much balance, one best example is how much balance he's having the fixed deposit or not in a bank. If someone is having fixed deposit and a particular amount of balance he is having, that bank manager will easily uh, give him the loan, right? Am I correct? I might be wrong also. Am I correct?
Yes.
Yeah. So there are several several independent variables. And my dependent variable is 0 and 1, means whether to issue credit card or not. Okay, got it? Everyone clear with the data set? Clear everyone, data set?
Yes.
Yeah.
Yeah. Or do you all know how to use SPSS? Are you using it in your SLP classes?
Yeah.
Yeah. So to run logistic regression in Excel, previously in the simple linear regression, one second, I have to close this set. So yeah, so to run the simple linear regression or multiple linear regression in Excel, that is very much easy, right? But to run the logistic regression, it's very difficult. You have to install some add-ins. Run logistic regression. To run logistic regression, it is not inbuilt function in Excel. You have to install some add-ins, then only you can run logistic regression. Okay, so better we will be using here the SPSS. So you will be interested only the output part. So what I'll do, I'll go to analyze, then where it is binary logic. Yeah, regression, then binary logistic. So my dependent variable here is which one? Default payment, right? Suppose I am taking only pay 0, pay 2, pay 3. From here 3 variable and a balance amount I'm taking 3. So total 6 variable I'm taking. I can take almost all those things, but I'm not taking right now. I might not be changing anything. I'll click on logit to get the logit function. Then I'll check the probability and group membership. Continue. Then options. I'll be taking the Hosmer Lamso and classification plot. I don't want anything. Style. I don't want to change anything. Yeah, just okay. Yeah, see this. Yeah, see this one. This first table, the variables in the equation. Can you see this? What is the meaning of that? This is the beta naught value. Step 0 means the constant value, the beta naught part, right? This defines the beta naught value. So this beta naught value is minus 1.259. The standard error is 0.015. Now can you see this wild value? Wild chi-square. Can you see this? How do you get that? In your simple and multiple linear regression, instead of this wild value, what was that? That was t, right? First column was b,
Okay.
then
Yes.
standard
Yes.
error, then t. So how we were calculating t value there? B by standard error, right? So this wild value can be calculated by using these two terms only. So the formula will be, I would suggest you to write this formula. So this formula will be b by standard error total whole square. Are you getting it? So they might give this particular table and they will remove this one. These two particular values will be given to you, B and SB, and they ask you to calculate the wild value.
Can you
Does
repeat
that
the formula points?
the
That
formula will be this B value divided by standard error SC value total whole square. First do it B by SC, then whole square. Check this particular term whether you are getting this particular value or not. The B value is minus 1.259 divided by, in the denominator it will be 0.014. Sorry, I can't zoom in the screen. It's not possible. So if you are unable to see, are you getting the same value? Can anyone
yes.
check and confirm?
The formula is B by standard error or square equal to volt, right?
Yeah.
Okay, I will check one.
If you have the calculator with you, you can check.
Yeah, I will check.
Let me check. 1.259 divided by 0.014 and whole square.
It's
So I am getting
8087.
yeah, I am getting 8087. Why it is? Let's check. Now write the entire value you have to write. It's 1.258687. Okay. Divide by, let's write the entire value of this. 0.1 sorry 0.013910 whole square. Now are you getting that this value?
Yeah, 8188.0.
Yeah. So it is approximated to 3 decimal point. So if I double click on this, I'll be getting this the entire value. Okay, and what is this? EXP bracket in bracket B. What is this?
Expected.
I already talked about this term. Just think about it and what is this? This particular term.
Is this the
This is the odds.
logistic?
This is the odds ratio.
Logic.
This is the odds ratio. Exponential B means what? E of e power this particular term. Do that e power minus 1.259. Can you check that value? 1.259. How much I'm getting? 0.2839. So e power beta means what? That is odds ratio, no? Correct. Got it, everyone? Hello?
We are doing e to the power beta.
Yeah,
Can
e
you
to
repeat
the
the last point? I didn't understand it.
this is EXPB. This is the odds ratio. What was
Okay.
the formula of odds ratio? E power beta, right? So this is same, right? E power beta naught. This is a beta naught I was talking about, the constant function. Okay.
Okay.
So e power minus 1.259. You can, if you can put it in your calculator, you'll be getting this particular
Yeah,
value,
it is
0.28.
coming
Okay, okay, okay. Fine, fine, fine.
It is coming as 0.284.
Yeah.
So in exam, beta value will be given and you have to find all these.
Yes. In exam, they'll give you the beta value and the standard error value. They ask you to calculate the wild value and this odds ratio value. There was a question in our time. Uh, in our time, actually, logistic regression was in NCP2 and our NCP2 was subjective type. So we got what on 10 marks question from logistic regression. So this was one part, like calculate the wild value. There was 2 marks question and calculate the odds ratio. Then this was 2 marks question.
Can you tell the formula for odds ratio 1?
E power beta.
Oh, acha. Okay.
Yeah. So this is all the scores, like the all the independent. This is a constant, right? After that, all the independent variable score will come. Next is, let's check what is important for you. Yeah, this Hosmer-Lamshaw. Hosmer-Lamshaw is important, right? So Hosmer-Lamshaw, what was that? Fit is good, null hypothesis, and fit is not good. So what is your conclusion here from this output? From Hosmer-Lamshaw, this particular output. Can you see this output?
Yes.
Yeah.
Uh, your significance value is 0.000. Means what? Significance means what? This is the probability value, right? So now you have to check whether alpha is greater than p, or p alpha is greater than p, or p is greater than alpha. Here alpha is greater than p, right? Alpha greater than p means what? Reject h naught. So your conclusion will be fit is not good. Am I correct? Am I correct?
No, can't understand. Can you repeat?
Hosmer-Lamshaw, what was the null hypothesis and the alternate hypothesis? Null hypothesis was fit is good, and alternate hypothesis was fit is not good. So here, this is the probability value. The significance means the probability value, and alpha value, suppose 0.05. I took my alpha value 0.05. So here alpha is greater than p. So what is the conclusion? If alpha is greater than p means, or p less than alpha, then what is the conclusion? Yeah. This is what is the conclusion from Hosmer-Lamshaw. I don't think any other output is required for you. So main part is here. They will give you this particular value beta, and the standard error. You have to calculate the wild value and the what to say. This is odds ratio value. Yeah. Next is they'll give you this table, and they will ask you to calculate what is the conclusion from this Hosmer-Lamshaw test. What is your conclusion from Hosmer-Lamshaw? So this will contain 6 marks question, right? 2 marks for wild test, and 2 marks for this calculate wild value, 2 marks for odds ratio, and 2 marks for this conclusion from Hosmer-Lamshaw.
How we calculate the wall value?
That is what I said now. B by this AC whole square. You got disconnected?
No, but I couldn't get it. Like my answer is not coming. Can you repeat the formula again?
B by AC.
So this
It's B.
SE will be whole square, or the whole thing will be whole square?
Whole thing whole square. Do you have a calculator with you?
Yes, yes.
Check this now. B value is minus 1.259 divided by 0.014. First calculate that and then put it in the whole square. Check whether you are getting this particular value or not. You will be getting
I'm getting
8087.
808. Yeah,
Yeah,
8087.
because this is you have to take the entire value. This value is still 3 decimal point. If you take this entire value, you'll be getting this particular answer. Okay.
Okay, okay.
Value is actually 258,687. So we have taken until 258. So that is why there is a deviation of 100. And here this value is also this is 0.013910. That is not a big deal. The formula is same.
Yeah, now I'm getting it.
Yeah. Got it, everyone?
Hello?
Shubhadeep, can you tell once again how do we have to calculate world?
B by AC total whole square.
Okay, okay.
And
Hello?
this
Okay.
yes,
No, you carry on afterwards. Yeah.
this is the odds ratio. Odds ratio you calculate e power beta. E power beta means what? This p value. Okay. Put it e power minus 1.259. You'll be getting this value 0.284. This is the odds ratio. Okay.
Hello, like regarding that goodness of it only, my doubt is on the
Okay.
Osman and
Yeah.
can you like repeat this statement? I will.
Hosmer-Lamso, the null hypothesis, fit is good, and the alternate hypothesis, fit is not good. So now you have the output. You write the null and alternate hypothesis for Hosmer-Lamso. Now you have, they will give you this output. The question will be like this. Let me tell you the question. The question will be like this. This output table will be given to you, Hosmer-Lamso. They will ask you to write the hypothesis. Write the hypothesis for Hosmer-Lamso test, and from that, what is your conclusion? This will contain 2 or 3 marks. So first you have to write the hypothesis that will probably carry 1 marks. Then the conclusion will be like, here's the significance value is almost 0. So let assume that my alpha value is 0.05. So here alpha is greater than p. So my conclusion will be reject h naught, means here fit is not good. Clear, everyone?
Yes,
I hope it's
clear.
clear. Any other doubt? We are done with the logistic. That is very simple part of logistic. I don't
One
think.
tell about odds ratio.
Wait 1 second. Let me stop the recording.